Hello students, this is a lecture for O-Levels Chemistry, and in this lecture I will be talking about Le Chatelier's principle and the dynamic equilibrium. The principle states that when a change is made to the condition of a system in dynamic equilibrium, the system moves so as to oppose the change. Which means if a system is in dynamic equilibrium and you bring a change into this system, the system will behave so as it will oppose that change. For example, if you increase the temperature for a system in dynamic equilibrium, then the system will behave in such a way so that it will reduce the temperature. Or let's say you increase the pressure in a system at equilibrium, the system will behave in such a way so that it will decrease the pressure. The change will be opposed. Now let's look at an example to see what this definition says. Let's say we have an equation here. Sulfur dioxide reacting with oxygen, it produces sulfur trioxide. This is a very important reaction in the chemical industry for the process of sulfuric acid or for the manufacture of sulfuric acid. Let's balance this equation. The del H of this equation, or the enthalpy change of this equation, is minus 197 kilojoule per mole. Now, when the enthalpy change that is given here, is always the enthalpy change of the forward reaction. The forward reaction is from left to right. The backward reaction is from right to left. We know that if we have a del H negative, we know that the reaction is exothermic. And we also know that an exothermic reaction liberates heat or releases heat to the surrounding. Exothermic reaction releases heat to the surrounding. And when heat is released in the surrounding, temperature increases. Temperature increases. This is our forward reaction. For the same reaction, the backward reaction is endothermic. If the forward reaction is exothermic, the backward reaction must be endothermic. And endothermic means it absorbs energy from surrounding, absorbs energy from surroundings, and this will result in a decrease in temperature. Temperature decreases. So, we have analyzed the equation. Now we will bring a change. Let's say this system is now in equilibrium, in dynamic equilibrium, and now you bring a change. The change that you have brought is, let's say you decrease the temperature. You decreased the temperature. What is the effect of reducing the temperature of this reaction? Now, according to the Le Chatelier's principle, the temperature must be increased. The temperature must be increased. And how can we increase the temperature? You see, if the forward reaction is faster or if the forward reaction happens more, then it will release more temperature. If the backward reaction happens more, then it will decrease temperature. My focus is to increase the temperature. The temperature must be increased. So what happens? Forward reaction rate. Forward reaction rate increases. You can also say the equilibrium shifts to the right. Equilibrium shifts to the right. So you see the definition, if you can recall the definition of the principle says, if you bring a change, that change will be opposed. You have decreased the temperature must be increased. And if you want to increase the temperature, the forward reaction rate should increase and the equilibrium will shift to the right. What is going to happen if you bring a different change? Let's say you increased the temperature. For this reaction, you increase the temperature. Then according to the principle, the temperature must be decreased. In order to do that, the forward reaction rate should not increase, but the backward reaction rate must increase. Backward reaction rate increases. Because if the backward reaction rate increases, that will reduce the temperature. So equilibrium will not shift to the right now, equilibrium will shift to the left. I hope you have understood how a temperature change is affecting the position of a dynamic equilibrium. Let's say we have an endothermic reaction. আমরা তো এখন একটা exothermic reaction we have discussed about a exothermic reaction. Let's say we have an endothermic reaction. This reaction is not endothermic, so let's say we change something. We change the equation. Okay. Just giving you an example. A plus B producing C plus D. And let's say the delage of this reaction is positive. A plus B producing C plus D, the delage of this reaction is positive, let us say. So if positive, then the forward reaction is positive here. And if the forward reaction is positive, then we know this is a endothermic reaction. And we know that endothermic reaction absorbs heat from surrounding. And the temperature will not increase, the temperature will decrease. The backward reaction now will be exothermic. See, the delage value that is given is always for the forward reaction, and the delage is positive, so the forward reaction is positive, the forward reaction is endothermic. The backward reaction should be opposite of that, it should be exothermic, and we know that exothermic reaction liberates energy to the surroundings and the temperature increases for the case of exothermic reaction. Now let's say you have brought a change. The change that you have brought is you increase the temperature. Now if you increase the temperature, according to the principle, the temperature must be decreased. I'm fine with that. Now how can I decrease the temperature? Temperature decreases the forward reaction. So we will say here the forward reaction rate increases, equilibrium shifts to the right. So this is an endothermic reaction. The forward reaction is endothermic reaction, and if you increase the temperature, the equilibrium shifts to the right, goes to the right hand side. The meaning of the word equilibrium shifts to the right is more C and D will be produced. More C and D will be produced. I hope you have understood now how Le Chatelier's principle defines or explains what happens to the equilibrium position. Now, let us look at how Le Chatelier's principle can or how pressure affects dynamic equilibrium position. Let me restate. How pressure affects the position of equilibrium, and we will try to explain that using Le Chatelier's principle. So we have an equation here. Sulfur dioxide is a gas reacting with oxygen, which is also a gas, producing sulfur trioxide, which is a gas, and this is a reversible reaction. Now, we don't need this temperature analysis anymore. We don't need this temperature analysis because now we are going to deal with pressure. Now you see, if you analyze the forward reaction, what is happening here? Forward reaction. I don't need the del H value for this analysis, however. I don't need this value for pressure analysis. So what is the forward reaction? What is happening in the forward reaction? 3 molecules produces 2 molecules. Or you can say 3 molecules of gas produces 2 molecules of gas. You see here 2 plus 1, 3 molecules of gas. From here you have 2 molecules of gas. You see, when the number of molecules of gas decreases, the pressure decreases. Let's say you have a container here, and if I give you 10 molecules here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If I give you 10 molecules here, they are going to collide with the walls of the container, and this collision will result in the pressure. Now if I reduce the number of gas molecules here, you see they will collide with the walls of the container less often in this new scenario, and the pressure will be reduced. The pressure will be reduced. So this is a very common thing. This is the idea of physics, where number of molecules decrease, that a decrease in the number of molecules will result in the decrease in pressure. So 3 molecules of gas produces 2 molecules of gas. Pressure decreases. So the forward reaction decreases the pressure. Let's see what is happening in the backward reaction. So for the backward reaction, 2 molecules of gas produces 3 molecules. Produces 3 molecules of gas. And this will definitely increase the pressure. So pressure increases. When this happens, the pressure increases. Now let's say you have brought a change. We have analyzed the reaction. Now we are bringing a change. Let's say this system is in dynamic equilibrium and we bring a change. Let's say the pressure change is you increase the pressure. Now if you increase the pressure, according to the principle, Le Chatelier's principle, pressure must be reduced or pressure must be decreased. Now how can I decrease the pressure? Here, the forward reaction rate increases. Forward reaction rate increases. You can also say equilibrium shifts to the right. Equilibrium shifts to the right. Equilibrium will shift to the right. which means more and more sulfur trioxide will be produced. I hope this is understandable. Now let us say for the same reaction, you decrease the pressure. Alright. So now if you decrease the pressure, what is going to happen? According to the Le Chatelier's principle, the pressure must be increased. And how can I increase the pressure? If I go for the backward reaction. So the backward reaction rate will increase. Backward reaction rate. And equilibrium will shift to the left hand side. Equilibrium shifts to the left hand side because the backward reaction rate is increasing. This is how pressure affects equilibrium position, and this can be explained using the Le Chatelier's principle. Alright.